Good day to you. Today we are going to see a flyback converter. So far we have seen a buck converter, boost converter, hash bridge. If you have not seen those videos, subscribe to my channel so that we can view those as a playlist under Power Electronics. This flyback converter is one of the most widely used circuit in the world. Every house will have 4 or 5 circuits of this nature. You may be able to guess what is that. It is our mobile chargers and most probably our laptop chargers too. This is Kadal Abudam from Chennai, India. Like our buck and boost converters, these flyback converters also has a switch, a diode, a capacitor, and instead of inductor we have a transformer. That is the only difference, and they are connected in the fashion ISO UK. And then the switch S will be operated on and off. Power will be transferred from primary to the secondary, and the secondary voltage will be rectified to get the DC current. This is the simple way of explaining this operation. Input is a DC that is converted again to another DC at the output. Mostly this will be used for step down. Input DC generally will be AC 230 volts rectified into around 270 volt DC. So DC will be converted into 5 volt DC so that batteries in the mobile phones can be charged. This is the current flow diagram. When the switch MOSFET is on, the current flows from the source to the primary winding and back to the source, and then the capacitors in the secondary side will be discharging into the load. When the switch S is off, the primary circuit there won't be any current, and the secondary circuit will be conducting through the diode. It will charge the capacitors as well as supply the load. This is a simple operation of the flyback converter. This is a waveform of the flyback converter. The top waveform is the voltage across the switch, MOSFET switch, and the bottom waveform is the current. Whenever the MOSFET switches, there will be current in the primary winding. So that is given in the bold line. Whenever MOSFET is off, there will be current through the diode winding, that is given in the dotted line diagram. So this is the way our flyback converter works. This is a little more detailed and practical circuit. In the input, DC will be obtained by rectifying the incoming AC from the mains by a diode rectifier and then given to the capacitor C1. That RCD are forming a snubber network. It will suppress any voltage spikes across the primary winding. S is the MOSFET is the switching element. The secondary will be rectified by the diode and given to the capacitors. There is a small error in this one. Here there is no galvanic isolation between the input and output. Generally, input to output will be galvanically isolated. That is the advantage of this circuitry. Input AC or DC will be galvanically isolated to the output. This is the end of this video, small video. The famous supplier for this type of IC is Power Integration. They give everything as a single IC, including the MOSFET and all control circuitry. You have to add one more, mostly you may have to add one more optocoupler and then the transformer and then few external components, and then the circuit will be ready. Power Integration gives complete design details for each and every component so that one can follow the guidance and make this type of power supplies easily. This is the end of this video. Kindly subscribe to watch more such videos in this Power Electronics. Good day to you. This is Kadal Amudam from Chennai signing off.